Welcome. This is an update video. In a previous video, I've shown you how to download and reconstruct CT raw projection data of a walnut. And this is where we're also starting here. I'm using this open source X-ray CT reconstruction GUI that I've written. It shows you the trajectory and it also allows you to set up the reconstruction volume. Now, I've done this a bit carefully to nicely cover the walnut. You can see this best in this projection view, where you see the raw projections, but also the green box overlaid. And I made it so that from any arbitrary angle, the green box always nicely covers this walnut. So I'm going to start by doing an initial reconstruction. I'm just going to hit Save and Reconstruct. And this is going to be doing an FTK reconstruction of the walnut dataset. So this is 720 projections of about 1,000 by 1,000. And it takes maybe about a minute on my computer to reconstruct this 4 GB volume here. I'm going to pause the video just because I don't think it's so interesting to you. And continue about a half a minute later. You see it's just finished the actual FTK reconstruction in about 10 seconds, and the loading and processing of the raw projection data is what took maybe 20 seconds. And this is the result. What you can see is that this scan has rather big misalignment artifacts here, so double edges and blurred edges, and all in all, it's not a very good scan. But this is what you would download if you just got the free data set. So I'm going to try and correct for this. So the first thing is I'm going to go back to the reconstruction GUI, but then I'm going to hit the blue ECC calibration correction button. So this is bringing up my epipolar consistency correction. And first of all, you have to select how many views do you want to use. I'm just going to be using every 10th view, which is 72 views in total, which is plenty enough to correct for any global misalignment parameters. So this is going to be about a half a gigabyte in memory, which is very fast. So we won't have to wait for very long. It now computes the random transform, and there we go. Right, so first of all, stage 1 is already prepared. This scan has a very strong axis, offset, and lateral direction. I'm just going to make a plot of the cost function. So this is now the epipolar consistency, or other inconsistency, plotted over the offset lateral parameter. What you can see is that the current state is not in the minimum. So if I just move the axis by about 0.1, I would get rather better inconsistency or less inconsistency. I can do this by just clicking the sweep 1D search button, and it's gonna just pretty much do the same thing we just did, but it's gonna pick the minimum, which is in this case 0.08 for the parameter offset lateral. I'm just going to say yes. It's now applied it to the trajectory. And if I hit run reconstruction now, and I'm going to call this stage 1, it's going to run another reconstruction, which hopefully has less double edges. I'm just going to pause the video again. And there we go. Yeah, well, just writing and loading this dataset also takes a bit of time because it's 4 GB each time. So maybe I should have unpaused a bit later. Okay, so this is the result. And maybe if you recall what it looked like earlier, this is a lot better already. But it still has double edges, like especially in this region here, there's definitely still a double edge going on. And also this is kind of blurred. Yeah, so I'm guessing there's still room for improvement. I can click View Results button and just click both of the reconstructions to load them both into this viewer, and then you can compare initial and optimized directly. And you can see that this axis offset is already accounting for most of the offsets in the scan. So what I can also do is I can check if the other offset parameter is good, and it doesn't look good at all. I guess I have to add some more planes here to improve the sampling because this looked a little rigid. Ah, okay, this is not the problem. I guess this parameter cannot be easily optimized, but how about these dejusts? Yeah, that definitely. and that also. So I'm going to click those as well, and I'm going to hit optimize, and I'm going to say yes. And this is now actually optimizing the axis dejusts. And you see there's still quite a bit of room of improvement here, 0.2 degrees, that's considerable. Also a bit of roll. I'm just going to click auto align and apply. Now this is new. What it does is it actually applies a global 4x4 homography that is also in a similarity that tries to align the central plane before and after this calibration correction. And this is because if you change the trajectory, that will also change where the central plane is positioned in the reconstruction volume. And in order to really compare two images, they should be sort of registered, so they should be in the same position. I'm just going to repeat the stage 1 reconstruction here because I've just optimized all parameters. And I'm going to pause again because this is not exciting. And here we go. This is not much better than before, but it's also not worse. Okay, so this is my starting point. And what I'm going to do now is I'm going to do a stage 2. I'm going to add a continuous motion. I'm going to be doing an object pose, and I'm going to be adding 5 control points. This will be translation and rotation in these directions. I can remove some of the tolerance so that it converges faster, and I'll just run the stage 2. This is now actually optimizing a total of 6 by 5 equals to 30 parameters, and these parameters are basically control points along the circle, and each control point changes the rotation and translation of the object. So this is the result. You can see it's really fast, but that's because we only use 72 views as reference. And these are the results. I'm going to again apply this and see if it got better or not. I run the reconstruction. I'm going to call it a stage 2. And again, I'm going to pause the video. And there we go. This is the result. And yeah, there's still quite a bit of a double edge here. This looks pretty good. Let's look at another. Yeah, no. I don't know. This is definitely not the best correction I've ever done. But in some places you can see it's actually pretty good. Very much depends on what you're looking at, I suppose. Yeah, this looks rather good, I think. Okay, so anyway, this is where we are. The last thing I'm going to show you is I have a run refinement button now, and I'm going to add another stage now, which I'm going to call stage 3 refinement. And this stage is special in that I'm just going to add a simple, let's say, object pose here, and I'm going to reduce this a bit. And I'm also going to add detector shift and detector orientation. As you can see, the pitch is the least stable, so I'm not going to optimize this one. And detector shift, U is known to be much more critical. V is known to be much better. And yeah, I'm just going to try what happens. LBFGS optimizer, I'm going to be using less accuracy and run refinement. And this is different now because it optimizes the parameters for each and every projection. So you see we're iterating through views now, and it's going to correct with respect to the 72 reference projections each other projection. And this is something that if you're already very close to the optimum and you change only a few parameters in a small scale, will improve the reconstruction, but there's also a high chance that if you hit a parameter that is not observable, or if you have views which are, truncated quite a bit, or you have other sources of inconsistency, may actually make things worse. But let's see what happens here. I'm just going to pause the video and we'll find out. Okay, so it's now corrected all 720 views in about 150 seconds. And I'm going to close and load the result. And this is going to be doing the reconstruction. You can see it's now called reconstruction refined. And again, I'm going to pause because this already takes a while. And this is the result. I can see that there's still a bit of a blur in this specific location. Let's check this view. Well, this has improved a bit, I think. Okay, so this is not the best result still that I ever had on this data set, but yeah, you can tell it makes sense to play with it a little bit. So now I'm just going to be doing a volume rendering of this, just to show you the level of detail that you can reach. Okay, so this is the walnut in 3D. I don't want the SVG overlay, and I'm gonna look at the ISO surface. I can adjust the ISO value. I guess in this case I'm gonna have to go down a little bit. Oh, this was too much. I don't know. Maybe like that. And you can see a lot of detail here. Yeah, so even the smaller ridges on this shell are nicely visualized. So this is working pretty well. The last thing I can do is I can cut this thing open. This is what it looks like inside. But for this type of visualization, it actually makes sense to do proper emission absorption rendering, in this case even shaded. You're going to have to adjust the transfer function a bit. And because this is actually something that takes a bit of time, I'm just going to load the preset that I already created. And this is what it looks like. And you can see that there's a lot of detail here. Even the smaller things in the walnut, like these ridges, it's all nicely visualized. Actually, I'm going to look at the other half of this walnut now. Whoop! There you go. I think there it's visible even nicer. Yeah, so all of this detail would not have been visible without the calibration correction. Not a chance. Okay, so the last thing I want to point out is you have this view results here, and I'm going to compare the initial, stage 2, and also the refine. This is going to be like 15 gigabytes already, so takes a bit of time to load. That's also why I skipped the stage 1. And here you go. You can now choose between 1 reconstruction. 2 is actually the best, and 3 is stage 2. So I'm going to be hitting 1, 3, 2 now repeatedly. 1, 3, 2, and 1, 3, 2. And you can see that, yeah, there is a bit of difference, but I guess I was hoping it would correct for these misalignments here, and it didn't. When I tried this earlier, I guess I had the settings a little bit differently. It actually did a better job at this, but you see, you have to play with it a bit. I mean, it definitely gets sharper, so I would say that it improved, but not by as much as I was hoping. Anyway, you can use this for free, and you can apply it to your own raw projection data, whatever modality it is. If it's like CT, either emission only or absorption only, you can do the correction, you can do the reconstruction. Yeah, if you like it, contribute, let me know. If you find bugs, also let me know. I'm really hoping that somebody will profit from this work. Well, thank you, and goodbye.